hopefully you would be enjoying, and today I'm going to add one more enjoyment. So let us take a closer look what we are going to do today. I'm going to deal and talk about a very interesting topic, that is the paradoxes. Hopefully you would like this. So paradoxes. So before going to the topic, let us understand what are the paradoxes. You might have heard that the people defines that they say that this is a paradoxical statement. So have you ever thought that these two words, that paradoxical and statement, are the self contradicting? If it is a statement, then it never can be a paradox. If it is paradox, then it can never be a statement, because we know about the definition of statement, what the statements are. So how do we define a paradox? A paradox we can define in this way. Paradox, an argument which contradicts its own hypothesis. Hypothesis or assumption. So in this video I am going to talk about the Russell's paradox. You might have heard about it, and hopefully you will enjoy this paradox. It is really very interesting paradox, which is a set theoretic paradox. And I would also, and you will also see, this is the reason that's why many of the great peoples or the great mathematician don't go for the definition of set, and also good teachers don't write the definition of set in their own books. So let us talk about the formalism of the Russell paradox. What is the formalism? For any set, I think you know the definition of set. How do we define a set? Uh, Actually, we define a set, or the Cantor's set theory define a set as a collection of the object, or means the terms like family, collection, and you can say the sets have the same meaning. So for any set we can talk about that, can it work as a element? A set can also work as an element, or a set can be element of some other sets. You might have seen, just like then we can talk about a set. Is this set element of it itself on or not? So for consider a set A be a set which is defined to be set of or we can say set of all students. So S be a student. Okay, so or you can say S such that S be a student. So this is the set of students, and we talk about the set A. Is this set A an element of itself? If we talk about the collection of students, then the collection is not a student, so it cannot be an element of itself. So we write it does not belong to it. Now consider a set B. nothing but its complement. Okay, that is set up all things which are not students. So we can say B such that B is not a student. Okay, now we talk about this set. Is this set element of itself? Because the set of all those things which are not a student itself is not a student. So clearly this set belongs to its own, or this implies B belongs to B. So it is clear that for a set to be element of itself, or it is not an element of itself. So we can say about a set that you can say, and we define some terminology. The set of all those sets is, or we can say the a set is called normal if it is not element of itself, and a set is called abnormal set if it is element of itself. So we divide the sets in two categories: normal sets and abnormal sets. Abnormal. What are the normal sets? That is, a set is said to be normal. A be a set is said to be normal if A does not belongs to itself, and B be a set is said to be abnormal, or abnormal set if what happens, B belongs to itself or B belongs to B. So in these two categories, now can we formulate a set? Let us consider a set, say we say S, okay, which is defined to be set of all those sets which are elements of, which is element of itself, means set of all normal sets. A be a set, A be a set. Which type of set? A does not belong to A. Okay, that is, it is set of all normal sets. And consider a set which is nothing but its complement, that is S prime, say, and it is A or B be a set, that is B belongs to B. Okay, so now we talk about this set, that is a normal set. Okay, the set of all things, or the set of all sets which are not element of itself. If we talk, now we talk about this set S. Is this set element of itself? When we answer this question about this set, that is set of all normal sets, that we can answer in two ways. If either it is true or it is false, this means either this is set up, either this is element of S, or it is not element of its own. This means either S belongs to S, or S does not belong to S. But if we answer this question in any way, we are stuck. This is called the Russell's paradox. So in next video we will consider it in detail and understand how the paradox arises. So let's hold here and bye. Take care. Hopefully you enjoy it.